All right, thanks guys. Hope you're not too sleepy, because we have 45 minutes. But anyway, so I'm going to talk about how we build two things, mainly experimentation platform and data ingestion pipeline to support all the scale, right? So I've been at Grab for about 2 years now, and one constant was there's always scale. There are always challenges to scale in both business and systems, really, right? So two topics are actually quite related when you think about it. So experimentation platform lets you try things, and data ingestion pipeline lets you observe things you try, right? And I'm going to dive into more details, right? We actually started just 2 engineers, and now we have about 15 people all in all involved, not all engineers. And a side note, we also have a center in Vietnam, in Ho Chi Minh City, actually. So the next on our team. So let's start with experimentation platform. So before I talk about experimentation, we need to talk about something which underpins experimentation in online systems, which are feature toggles. Just, I need some kind of feel of this, of the audience. How many people use or heard about feature toggles? Right, not that many, right? So feature toggles are super important when you have any kind of product which you push regularly, right? They let you do several things. They let you gate feature deployment, right? So for example, you might want to push a binary out and it's not ready yet, right? You push it out and then, well, you can't just let it unfinished feature to the wild, right? But you need to keep shipping, you need to keep deploying your software. When you think about backend system, even when you think about traditional software, so Microsoft, when they did Visual Studio, there's tons of feature flags in Visual Studio. However, well, they ship the binary, they sold the box, but they're not enabled there, right? So same principle applies here. And so features is one thing. It can be static, like in case of Visual Studio, it's a static features. In a line system, they can be dynamic. In fact, they can be dynamic features. You can think of them, you can control them on a customer basis, so someone will have it enabled, some other person will not have it enabled, right? Things like Facebook, they use this extensively, right? If you want to read more about this, Martin Fowler here has a great blog post on feature toggles in details, and you can even think about this feature toggles as when you do canary deployment, well, you're really just doing testing, right? So we started this maybe a year and a half ago, and the mission was to accelerate innovation at Grab, really. As company grows, there's more teams, there's more stuff going on, and we really wanted to promote a culture of experimentation, right? We didn't really want our highest paid person, called a hippo, dictate to what we should build. We should be building based on data, based on concrete metrics, based on what customers really need, right, and what actually works. But to do so, we need to lower the cost of experimentation, right? How many of you guys know what A/B testing is? So, a bit. Right, so, in a nutshell, there's a crash course on A/B testing. Let's say you have a website, simple, and you want to change something. You want to try maybe a new color of a banner, right? Let's say here you have a website with red banner, and you want to see whether a green banner actually does better, right? So what you want to do is you want to test, ideally in a controlled environment, test the green banner against the red banner, right? And what you do this is you split your populations. Let's say you have visitors going to your website, so half of them will get red, half of them get green, and you want it to be done in an unbiased way. This is super important, right? It has to be unbiased, so ideally it should be random on who you are or like what country you're from, you just throw it out, right? And then how do you know whether something is actually working or not? You typically look at the metrics, right? So you make a decision, this guy gets green banner, the other guy gets red banner, right? And then you look at the metrics, maybe click-through rate. How many people actually click on the banner, right? So the click-through rate will be your metric, and then you assign users using some like Bernoulli trial, right? So there's many other types of experiments actually. This A/B testing is just one of types of experiments, but that's the idea. You want to measure things, you want to try things, and you want to make sure of your results, right? And so before we had built experimentation platform, at Grab actually we were running experiments. They're just very manual and very kind of connected to the process. So had business owners, product managers scheduling meetings. They would bring engineers, data scientists, analysts all together in one room, and they say, hey, we want to run this experiment in Singapore, blah, blah, blah. And then, well, go ahead and implement it, right? Then the service owners would go and implement the logic of A/B testing in their service. They deploy it to production. And then service which has metrics, for example, would go and implement some logging and as well some metrics measurements, right? And then we had a data ops team, which would build the data pipelines in Spark and things like this, and push it to S3, and which eventually went to Presto, so you can query it, right? And then analysts would go and build dashboards and analyze this. So this whole process, it was actually very slow. It was weeks, sometimes even 1 month to get one experiment done, and a lot of communication, a lot of effort, right? So let me give you an example of one of the first things we actually did to try to fix this with experimentation platform, right? And this is one of the very first experiments we ran. So the idea was, what people wanted to try is, hey, we want to send this message in Grab chat as soon as booking starts, right? And this message just says, we have some, here's a pickup address, and can you provide some more information? So they already had experiment running before that where they actually assessed whether this actually improves cancellations, so decreases cancellations, right? Now they wanted to figure out, what if we send it like 30 seconds after booking start, or 60 seconds after booking start, or 90 seconds, right? Which one's the best? So that was the experiment design, right? That's the important part. So that's what they wanted to do, and also wanted to constrain it on Singapore Grab Car and Grab Car Premium and just Grab, right? Just our vehicle types, verticals, right? Again, the hypothesis was they would consistently reduce cancellation. But as I mentioned in the A/B testing, you have a metric. So our cancellations was actually the metric for this experiment, the goal metric, right? So, right, so this was kind of anecdotal, right? It will be told to people, and they had to somehow implement it. But we wanted to build a platform to support all those cases. So the first thing we did is we looked at this, well, how many really different experiments you can do, right? And can we build something which lets you design your experiments while making it digestible by machine, so we can validate it, so we can run it, and know what we're doing, right? And being completely deterministic. So first thing we did is we said, all right, we'll create some experiment definition, and you can think of it as actually just a JSON file, right? Where it denotes what you're trying to change, how you're trying to change it, and what's the target population you want to target for this experiment, right? So in this case, we have a variable. So a variable is something you want to change, right? This delay, how many seconds, that is something you actually can change. Cancellation rate, you can't just change it. I can't just tomorrow say, I want 0 cancellation rate. It doesn't work like this, right? I can't just create $10 billion in my account, like, unless you use blockchain maybe, but besides that, I don't know. Anyway, so in this case, we have automated message delay, which is a variable we can change. We have a weighted choice, which says, well, how do I want to change it? So 70% of all the bookings get the value 0, it means no message is sent. 10% get value 30, so 30 seconds, after 30 seconds we send a message. 10% get 60 seconds, and 10% get 90 seconds, right? So, as well as we have some constraints. So this experiment should be constrained on, first of all, in time. So you don't want to run experiment for months, right? It's constrained in time, and then constrained on several verticals, like taxi types, we call them. Right? As well as by formalizing it, we could build a UI to actually manage it and make it kind of easier for people to design experiments without now scheduling meetings, right? So they could schedule meetings, they could generate JSON. That's the first part of it. Then we also built kind of a dashboards, so what you can look at experiments running, what state they are, who's going to create them, who's running them, and all the variables, so all the feature toggles, right? Then what we had to build, now that I had formalized this experiment definition itself, we could go ahead and build SDK, right? And well, at Grab we're doing microservices, and it's hundreds of, I think 200 or something microservices. What you don't want to do is you don't want to have a web API, and every feature flag you don't want to just give them value, right? Because now you have 200 services talking to you, and it's not very good. Like in of your time as an engineer, you don't want to get paged at 2 in the morning because hey, this guy couldn't get their value, right? You want to make the system super reliable, right? And to make systems super reliable in a microservice architecture, ideally you just don't want to talk to each other, right? So, being that we knew that all the 200 services will have to talk to the service, we didn't want to create, even though it's a service, would create a sort of single point of failure in the system. So instead, what we did is, well, we know that what they want to do. Can we make the whole thing completely deterministic, regardless of who's running where? So we never use random, right? And well, we just ship those definitions into microservices, all of them, right? And that's what we did. So each and every microservice would run our SDK, which would then asynchronously fetch those definitions, right? As soon as get changes, get parsed internally, and then every time you call get variable, the SDK is the experimentation platform logic, so it just actually runs the logic, right? So now in this case, in GrabChat service, you had get variable called, like give me the value of this variable, right? And if you remember here, is the same name, right? We use the same name. And not only this, give me the value of one variable, you also give some context. Hey, which city is this call for? Which vehicle type it's for? What passenger ID it is? What booking code it is, right? And the variables can be different types. So in this case, it's int64, and 0 is default value, right? So if for some reason there's no experiment running, there's no feature flag, or a system is broken, they get default value, and engineer gets to put this default value and know what to do with it, right? In this case, maybe send a message. Similarly, in booking service, for example, where you want to observe the results of this particular experiment, you would have a metric. You essentially just want to log something. So as well, we provided a tracking functionality, so you can just track the same thing with some context, right? Vehicle, passenger, booking, etc. Right? So, reiterate further, why did we even bother having this context, right? With this weird thing with the facets and things. Well, we didn't use, we had a feature toggle system, we used to call it sidevar. I think it was inspired by Facebook, if I remember well. And it was static. It was, hey, here's my feature, here's my default value, some numbers, I don't know what they are. And was just that. And the implementation was actually a shared Redis, right? And as you can imagine, as number of services grew, this Redis became a bottleneck and things would fail. And I think we had staging, so not that bad. We had a case where someone accidentally connected to Redis and flashed all the keys, and well, staging was gone. Right? So not fun, right? So that's why we rebuild this. And the context, the facets, actually provide a dynamic context. Right? So based on the facets, we can decide what the value to retrieve. So if we know we want to tell this particular passenger, give the specific value of our feature flag, we can do that. Right? Similarly, we have the track function, and we have some helper functions to kind of pass this context around. So you can inject those facets into a Golang context, and we'll create a new Golang context which carries over the function call. Right? And on top of that, we also have kind of inject globally. So we use open tracing, and we can inject some context in open tracing, so it can carry through microservice calls as well. Right? Now talking about this a bit more, we have now we had facets, right? We basically can think of it as a key value store, like a map. But we needed a common vocabulary. So we actually went and see what's the common things people do. Like they need passenger ID, they need driver ID, they need kind of vehicle type, booking code, maybe location. So we created a dictionary of those, and we provided an SDK. Right, this is actually very important, so that different services, when they say booking code, this enforces the key is the same for all the services. And we can understand what's a booking code, right? Because some people might write booking underscore code, some people might say BKG code or something like that. So this unifies it, creates a common language. Right. So in very, very high level architecture, that's how it looks like. So we have our SDK, which resides in all the backend services. We have our configurations, our JSON definitions, which live in basically S3. Then we have a planner service, which kind of orchestrates all the planning, all the scheduling of all the experiments, or like does a heavyweight validation and make sure the experiments don't interfere with each other. That's our core logic, and a lot of work goes in the planner service, right? But at the end of the day, they just create JSON files. So the SDK doesn't care. And then we have a MCD gateway, which is, so data flows into MCD gateway, right? Because you need to observe, so you need to track things at the end of the day, right? So you need to track things, and even when you get a variable, you need to track the result of get variable, because now the actual logic happens on the client, right? So this. And when you think about tracking as well, what we did there is, well, we're not going to track every single event, so we're just doing batching and shipping it asynchronously. So the worst case scenario is, let's say, everything is down, right? So let's say MCD gateway is down, well, we don't get data. Well, too bad. That's okay. Services are still fine. Planner is down, well, we don't get to create new experiments. Services are fine, experiments are still running. S3 is down, we'll have bigger problems than that, but it could happen. So even if S3 is down, we still have the default value in code, right? So services will still be fine. And when we talk to things like MCD gateway and even get fetching from S3, we obviously use circuit breakers and retries. And I think our next speaker will talk about this a bit more detail. Right, so data flows in MCD gateway and then ends up Kafka and ends up in Presto. Presto is a kind of SQL query engine, distributed SQL query engine by Facebook. Right, so that's all for kind of experimentation. We actually have a few blog posts on that, so I encourage you to read our blog because it's too much to kind of fit in one talk. Now let's talk about this data ingestion part. So after building an experimentation platform, and initially we did it in Go, we said, well, it really works. Now we want to have it on our mobile apps as well. And we really need to think and scale our data ingestion part. Right? When you think about doing this tracking on a large scale with millions of apps in real time, you need a lot of scale, right? And we needed to build it kind of from ground up. And I think last week at peak, it did about 500,000 events per second, right? Yeah, we were still fine. Right, so why do you want to do this? Why do you want to capture all kind of events? Well, if you have a generalized data pipeline which captures the events, you can do a lot of things. Obviously, experimentation is just one of the use cases, right? But you can do funnels, know kind of where your customers, how they interact with your apps and things like this. You can think of even funnels for backend services, right? You can do monitoring and login. In our case, we do monitoring and login on a mobile app using MCD gateway, right? And you can do things like user profiles and kind of build machine learning models and whatnot on top of that. Right. So we started with Go, then we built basically Android and iOS SDKs, and we built, at first we just built the tracking capability, right? We are actually in process building experimentation as well, a bit differently. But even experimentation resides on capability of tracking. You need to experiment and actually observe their effects, otherwise there's no point. Right? And again, this had to deal with persistence, quality of service. Mobile apps are tricky, to say the least. Right? And also build some kind of automated tracking. Right? And again, even our mobile case, we have the same context, so we have the same booking information and basically the same map, same vocabulary of things, and you can track those. And what's more important to us is, well, you can track a lot of data, but it doesn't mean anything if you cannot actually retrieve the data and do something about it, right? So obviously you can do some pre-aggregation and things like this, but for experiments, when you think about it, they're highly dynamic in nature. So you need to actually eventually SQL query it or get like raw data at the end of the day, right? So in our case, you could track an event, and then you can fire your SQL client, connector, Presto cluster, and well, query it in SQL, right? Things get a bit challenging when you have like petabytes of data, literally. Obviously, you have to partition data properly, so partition by time, right? But in our case, we're also partitioned by kind of event families, right? Think of an event as like what we had here. Here, actually. Here's custom event, right? That's an event name. When you think about it, it's actually just a metric name, right? Give it a name, doesn't matter what it is, just a name, so you can query it later on. So in this case, you select, compute some aggregation, and then maybe group by city, right? You can think of it, you could group by experiment and things like this. Right, so now to get to this SQL, actually a big challenge. So that's how more or less our data ingestion pipeline looks like. So we have different SDKs. We have Dart and JavaScript on progress. They all send data to MCD, right? Which does some processing, some security features. It does things like authorization, where you have the right to access, like to publish data. Ends up with massive Kafka. One massive topic, big topic. Then it kind of gets into two places. So we have a Spark batch. So we had used to have Spark streaming and Spark batch. Now we just have Spark batch, and we wrote kind of Spark streaming in Go. So what it does, it gets the data, and it writes the data into a columnar format. So we actually, in Grab, we use typically a Parquet and Orc. So we actually went with Orc for this case. Right. So everything gets to S3, right? Then Presto runs with type over S3, right? Presto is really good at that. But what we needed to do is, well, it's nice, but typically you cannot just scale it and get kind of both best of both worlds. Get some real-time data as soon as possible, and then having like petabyte of data, right? You need to play with it. So what we really needed for some of the use cases, when you think about monitoring, when you think about even short-lived experiments, or observing the results of experiments, especially when they're negative, like cancellation rate skyrockets, you need to do something about it. But to do something about it, you need to know when it happens. To know when it happens, you need to actually monitor it, right? So for monitoring, what we wanted to do for monitoring business events, we actually wanted, hey, why can't we just SQL query it, right? Why can't we just SQL query anything, including real-time data? So it's actually easier said than done, especially when you have, I think we have 2 terabytes incoming of data per hour. So we need to SQL query 2 terabytes. It doesn't fit in MySQL very easily. So how do we did that? So we built something called StalkerDB. It's actually really simplified database. And when you think about it, that's an example of actually query. I censored the metric name, but you would fire a SQL client. This is Metabase, and point to a table, and this table is actually real-time data, right? And this real-time data for the last hour, and you could, for example, just count them or group by or anything. And in this case, I counted all events, and there's about 4 million of them. And this query actually lifted 4 million rows into Presto, did the count, returned all results, and all of that under 1 second, right? So really fast. And this data is really fresh. So how did we do that? Well, in performance, it's really easy. If you want a system to be fast, well, don't build it. It'll be faster, right? When you think about it, right? The fastest way to work is not, right? You didn't hear me. So the fastest way to do not to do any work, right? Like this microphone, right? So ideally, you want to retrieve the data only what you need, and to make retrieval fast, well, the retrieval should not do anything. Right, so we built this database, and there's actually alternatives we explored. We explored like all of them, and at the end of the day, we felt like we needed something simple, something operationally what we can operate. Like we didn't want to have a massive Zookeeper cluster or run software we really didn't fully understand or didn't do the job. So we opted to build in this. It actually turned out quite easy with Go. So what it does is it only talks to Presto. So Presto only talks to it. There's no other way of getting the data, only going through Presto. And Presto would have 2 tables, cold or warm data, which is just your S3 files. And then for the last 1 hour of data, it will call our Stalker database, which essentially is a log-structured merge tree where the values are the metric name and time as keys. Sorry, the keys are metric name and time, and the values are a columnar structure. In fact, what we did is we created a columnar format that requires no unmarshalling, right? So I can explain a bit later. Right, so Stalker just downloads asynchronously those smaller, like 30-second files as they get published to S3, ingests them in itself, and then you can query them. Right. So ingestion, so here's a bit of code, but the ingestion happens is relatively simple, but you split by metric name in this case. Split in smaller chunks, because when you think about it, last week we had 500,000 events per second, right? That's like in 30 seconds, so 15 million or so, right? It gets a lot of data, right? So we need to split them smaller chunks, but keep it batched, even for retrieval, really important, right? Especially when you deal with big data, you need to have bigger batches. You need to batch everything and make sure it's really optimized for large scale kind of gather, right? So we receive all org files, we encode them, and then kind of the encode does the magic of making sure the data structure mimics the whatever needs to be retrieved, and then we just append this, right, to create a key. We actually use Badger key value store, which is really nice. It's used for a dgraph kind of graph database, but their key value store is really optimized for SSD, which came really handy, and it has really high both write and read throughputs, which is quite rare, right? So Presto is a query engine, and kind of to show you how it works. Well, how do you even talk to this cluster? So Presto exposes different connectors, right? It has connectors for Cassandra, it has for, I think, InfluxDB and things like this. So how do we build one? So what we did is we basically read a lot of documentation about Presto and understood how it works. It's actually quite simple. Presto first queries one of your nodes, say, give me this data, where this data is, right? They call them splits. Let's say you have a massive cluster or massive data set. Maybe you have 10 machines. It queries one of the machines, hey, give me the data. And what we do is, like in this case, so all the machines talk gossip. So they all gossip with each other. So 10 stalker nodes will talk to each other. They know what's the cluster state. And when query comes, we just simply return, hey, there's 10 machines. So your data is on those 10 machines. Then Presto comes back on every single machine and gets the data. So really, we don't do much. Presto does most of the work, right? And now we optimize this horizontally. Now, it's also important for really cost perspective to make sure it's fast, right? When you know a metric, when the query comes, you kind of know, well, what's a metric? In fact, if you try to ask the system for every data, it will not let you. It will just fail the query, say, yeah, no. Right? So it's important to provide a query. And you could even provide a time window, right? So by basically only scanning all the keys, we know exactly where you should start, where you should end, and we know all the columns you want. So one of the columns the query wants, like query might want to only get, some passenger ID, right? Only wants to lift passenger ID. There's no point lifting like all the data, all the facets. We only want passenger ID. So obviously the file is organized columnar way, so column per column, and only would lift the right columns, right? And as I mentioned, you don't want to do anything. So in fact, what we worked quite a lot is trying to make sure that the read path is really optimal, right? And you can actually use, Go benchmarks and actually write micro benchmarks for every single step and look at things like allocations, how much time it takes. Right? We optimized almost to zero allocation, really. It's constant allocation. It doesn't matter if there's 10,000, 100,000 kind of rows yet to lift. Right? So that gives you a few benefits, actually. So A, yeah, you optimize in one node, but B, because Presto actually does distributed gather of data, now you're adding more servers to your cluster, you get in two things. Typically, you add in more nodes and you're optimizing for throughput, right? You have more nodes, I can process more data. Great, we get this. But now, we get more nodes, we can process more data, and we also reduce in latency, right? That's about it. So, yeah, as I mentioned, Grab is hiring, so please join. There's also will be a blog post next week on Stalker kind of in more details. And there's a few blog posts on experimentation platform as well in our engineering blog. So I can encourage you to read them. All right, thank you.
Okay. Okay, let's move to the Q&A part.
So, right. So for numbers of our data pipeline, as I mentioned, at peak it's about 500,000 events per second. So the new pipeline having started quite recently, it's actually I think half of petabyte right now data set for I don't know, 2-3 months. Half petabyte compressed, so actually snappy compressed. So uncompressed, we're talking about 2 terabytes per hour. So can I get more details on what type of SQL?
The SQL query which you had in your example, you were only having like one where clause.
Right.
Yeah, and it was pretty basic count query.
Right. So I cannot show real SQL query because data private, but it can be anything. So essentially, you have a lot of columns. So all the passenger booking, they are just columns. It's a big table type of thing, and you can group by, do whatever you want to do, unnest. Some queries are really big, so analysts can write like several hundred lines of queries, right? So anything really. You can group by in Presto, you can approximate histogram, something like this. Right? That's where the power is. It's not pre-aggregated. You get raw data. It's all there. You can, whatever you want, you can get it. How do you deal with high-dimensional data in SQL? Great. So two questions here actually. So as I mentioned, we actually have a high-dimensional single event, and when it makes sense, we also unroll them in a separate events, right? But typically, we want to include an actionable event with all the information it needs. Things like city and location and whatever you want, right? So it makes processing job much easier because, and think about it, you have 2 terabytes of data. Well, don't try to join 2 terabytes of data with another 2 terabytes of data, right? Right, so for PAX user IDs, actually they're the internal user IDs, so we don't know who it is. Right? It's private, and we're actually very careful about it. Right? Does this answer your question?
So I think that's all for the online. And is there any question in the auditorium? Okay.
Hi. Can you talk a little about the young gen, old gen interaction between Stalker, Presto, and S3? It would appreciate a little detail there.
Right. So in the article we actually mentioned will publish kind of another article on data pipeline, which is pending edit. But essentially, Presto will have several catalogs. So essentially, you have one table for hourly data pipeline. So all the events for the hour per hour. Then we compact them into daily, right? And then you have a separate table for real time, which only keeps 1 hour of data. So as an analyst, as you kind of user, you would have to know, hey, do you want real-time data, which is really hot, or you're okay, you want to analyze like historical data? So you obviously can combine them both. They're actually same schema, so you can still do a union all query to get both data sets. But we expose them separately because they kind of serve different purposes, and it makes sense. Right, so on the real-time dashboards, business dashboards, you want the real-time data. You don't really care about, well, what was 3 years ago. But for analytics, you do care.
So you mentioned schema. So I guess the schema for, I think the data that is coming in is pretty generic. It's coming from just about anywhere. So the schema is kind of maintained by Presto here?
Right, so schema is very generic. So we have event name. Think about the metric name. Then you have a set of predefined columns like passenger ID, booking code, etc. And then you have a kind of arbitrary key value map. So as a column, you have this map column of data. So whatever you want, you put in this column as well.